Hello my schoolers, this is my school channel and today we'll be solving the 2019 past question for JAMB in chemistry. So in this clip, we'll be solving questions number 31 to 50. So make sure you check the link in the description below for the other videos. So join me as we go to question number 31. At 27 degrees Celsius, 58.5 grams of sodium chloride is present in 250 cm³ of a solution. The solubility of sodium chloride at this temperature is, so we're given the molar mass of sodium chloride as 111.0 gram per mole. Okay, so let's solve this question on molar concentration and its solubility. Okay, very well. So we are given the mass of the sodium chloride salt, which is your normal salt or your table salt, as 58.5. Okay, so at first we are asked to find the mass conc, the mass concentration. So recall that mass concentration equals, your mass in gram over your volume in dm³. All right, so, and we are given the volume of the sodium chloride salt as 250 cm³ in the solution. Okay, so we have 250 cm³. All right, so if we are bringing this to dm³, that makes it divided by 4 of 1000. Okay, so that means this is 1000 divided 250. Okay, so this is definitely 4 of it. Okay, so that means 1000 cm³ is being divided into 4 places. Very well. So that means 250 cm³ is 1/4 of 1000 cm³. So let me replicate what I've just said. So 250 cm³, is 1/4, isn't it, of 1000 cm³, where 1000 cm³ also means 1 dm³. All right, so that means if we are bringing 250 cm³ to dm³, that will be 1/4, 1/4, and that is 0.25. Okay, so that means our mass conc will be equals to our mass, which is 58.5, divided by 1/4, which is still 0.25. All right, so when we divide this, we should have 2.34. This is in gram, this is in dm³. They are units, so we should have gram per dm³. Okay, or preferably you can have it like this, whichever way, gram per dm³. Okay, so already we have our mass concentration as this. So we can have our solubility for the molar concentration as mass concentration over molar mass. Okay, so we can have this as mass concentration over molar mass. So we have our mass concentration as 234, divided by our molar mass, which is given as 111. Okay, so when we divide this, we should have about 2.111 and what have you. So if you want to approximate it, we can say our molarity for the solubility is 2.0 mole per dm³. So let's go through our options and see which of them tallies with what we have. So 2.0, that is option A. With me, I have question number 32. Which of the following properties increases from left to right along the period, but decreases down the group in the periodic table? Okay, so we have atomic number, we have ionization energy, we have metallic character, and we have electron affinity. Atomic number is the number of protons present in an atom. Okay, so it doesn't fit what we are looking for. We have ionization energy. Okay, that is the energy required to remove the valence electron from an atom for it to become and aeon. It's about electron loss. And there are three factors that you consider when it comes to ionization energy. You talk about the size of the positively charged nucleus, the nuclear charge, okay, the distance of the outermost electrons to the nucleus, then the Skriner effect of the innermost electron. So it increases across the period and decreases down the group. So this fits. So we are sticking to high, okay, just keep that with you. Then we look at metallic characters like electrical and thermal conductivity, okay, which doesn't fit with this, okay. Then we have electron affinity. That is like a complete opposite in this regard to ionization energy, where this talks about electron gain. That is, a gaseous atom gains an electron to become a negative aeon, and the energy released is what describes electron affinity, and it increases across the period from left to right and decreases down the group. So that implies that II and IV fit our option. So which option carries these two? That is option B, II and IV. So question number 33. Okay, so the molecular shape and bond angle of water are respectively what? Okay, so water, we have the oxygen, then the hydrogen. So it's like a V shape, okay, that is bent, and it's about 104 to 105 degrees. So we can typically bring it to bent shape and 105 degrees. So we have option D. Option D is very correct. So my scholars, you definitely need to practice so that we increase confidence and accuracy in dealing with these questions. All right. So for this, you just have to go and download the Myschool app on the Play Store, or you can download our CBT exam software for your laptops and computers, and they are all available and accessible through our Myschool website. Okay, so I've also provided a link in the description below where you can get them right now. It's all simulated for your experience and for your learning. You're going to enjoy it. So now let's go to question number 34. Okay, so we have sodium carbonate and hydrochloric acid to give you sodium chloride salt, your normal salt, water, and carbon 4 oxide. So the indicator most suitable for this reaction should have a pH equal to what? Okay, so to look at this at first, you will realize that sodium carbonate is a salt, but it's actually a very strong base. Looking at sodium chloride, that's a very strong acid. Even in the stomach, it has a pH of about 1.0. So having a strong acid and a strong base, we are told that any indicator may do. Sometimes you will say that the first stage of the reaction, phenolphthalein is used, the second stage, methyl orange. But I will recommend using methyl orange because it has a sharper endpoint. And methyl orange has a pH scale of about 2.9 to 4.6. Okay, so looking through our options, definitely the pH of the indicator recommending methyl orange is 3. That's option C. So don't forget to hit the like button, click on the subscribe button, and always tap on bell notification to get informed as we release the next videos. So we are tackling question number 35. Okay, so a radioactive nucleus has a half-life of 20 years. Starting with 100,000 particles, how many particles will be left exactly at the end of 40 years? So looking at half-life equals log 2, which has the value of 0.693 over the radioactive decay constant. Okay, so that is for the formula for half-life. But we can just use a very quick and short method. So just join me as we use logic. So if it has half-life of 20 years and it starts with 100,000 particles, so that is after 20 years, half of it will be lost. So that is after 20 years, we just have 50,000 particles left. So the next 20 years to make it 40 also means that another half of these particles will be lost. So at first, after 20 years, we lost half of 100, which is 50. The next 20 years, we are going to lose half of the remaining 50, which is 25. So definitely our answer is option C, 25,000 particles. Right here we have question number 36. Okay, so which two gases can be used for the demonstration of the fountain experiment. Okay, so first, the fountain experiment is actually to show the solubility of ammonia. So I've already given you a clue. So looking through the options, you should have a clue by now. I just mentioned ammonia. So this is what the setup looks like. Just think about a round bottom flask, okay, so filled with ammonia gas, hydrochloric gas, or sulfur dioxide gas. Okay, so let's just pick ammonia now. I'm just giving you another clue again. I've mentioned ammonia gas, sulfur dioxide, and hydrochloric gas. So ammonia is being filled into these flasks, okay, and the tip is being tied with a rubber bung, and some few droplets of water is being introduced into the flasks. On doing that, the ammonia dissolves in these droplets, okay, and that decreases the pressure inside the flasks. So the pressure in the flasks is lower than the pressure in the atmosphere outside. So this makes the water outside to flow in from another inlet into the flasks, okay, which creates a fountain site, a fountain effect. Okay, so going through our options, the kind of gases that we use for the fountain experiment, we have ammonia, we have hydrochloric acid, we also have sulfur dioxide. So just join me as we scan through our options. So we have option A, SO4 and NH3. We have SO3 and NH3, no. We have HCl and NH3, very correct. We have SO2 and CO, so this is not balanced. So this is definitely what we are looking for, hydrochloric gas and ammonia gas, option C. Alright, so we have question number 37. Which of the following pollutants will lead to the depletion of the ozone layer? You know, ozone has the formula of O3, okay? Alright, so let's go through the options we have. We have chlorofluorocarbons, that is CFCs, and they are being emitted from our refrigerants, our coolants, our ACs, and the rest, and actually they affect the ozone layer. They lead to the depletion of the ozone layer. Others like methyl bromide from our pesticide, okay? So let's just take carbon somewhere, okay? Option A. Let's look at carbon 2 oxide or carbon monoxide. Okay, this is very useful when it comes to extraction of metals. You get them when carbon doesn't bond or is not well combusted in the presence of sufficient oxygen. Okay, so you have that kind of experience too in gasoline when there is an incomplete combustion, okay, in our vehicles. All right, so carbon monoxide is out of the picture. So looking at hydrogen sulfide, it actually is also produced when there is a breakdown of a part of a plant or an animal, usually from natural sources like from swamps and bogs and the rest, and even from volcanoes to an offspring, they emit hydrogen sulfide. This is when breakdown occurs and there isn't enough oxygen, okay? So this being exposed to the atmosphere, of course, is a pollutant, but not affecting the ozone layer directly. What it does is it undergoes chemical and photochemical oxidation, which in turn produces this sulfur 4 oxide that causes acidic rain. So we've combined the two together. So definitely these two are out of it. Carbon monoxide is out of it, and definitely this is CFC, chlorofluorocarbon. Option A is correct. So do not forget that we have several solution providers on the Myschool website where you can ask your questions and get clarity on any of the solutions we have provided so far. So I've provided the link in the description where you can ask your questions right now. Okay, so we have question number 38 before us. Which of the following describes the chemical property of acid? So we have three chemical properties of acid that we will be talking about right on the spot. So first, they react with metals to liberate hydrogen gas, okay? Although an exception to this rule is dilute triazonitrate 5 acid, okay? Secondly, we see that acid reacts with insoluble bases and alkalis to produce salt and water. So option C would have been what we should go for, but we are having salt and carbon 4 oxide, so that is not what we are looking for. So another characteristic of the chemical property of acid rather is that they react with triazocarbonates, okay, to give us salt, water, and liberate carbon 4 oxide. So definitely option D fits into our option. So option D is very correct. So in case you have explanations, you have suggestion on how to improve any of the questions we have solved so far, or probably you have 1 or 2 steps you would like to add, don't forget to drop this and indicate the number in the comment section below. Okay, we have question number 39. Which of the following pairs cannot be represented with a chemical formula? So which of them, these pairs, can we not put out a formula chemically, outrightly for them? Okay, so let's look at option A, air and bronze. Okay, when we look at air, we know that the major components of air includes nitrogen, oxygen, okay, nitrogen of higher percentage, oxygen of about 21%, and the others as mixture, the other gases, okay. And looking at it, the composition of air vary with places, okay. So the composition of air, like in the desert or in a clay environment, will be different, okay. So because of the variety of the difference in composition, air cannot be represented with a chemical formula. Let's look at bronze. We know that from time, bronze is actually made up of copper and tin. But modern times now, tin sometimes is not even present at all in bronze, okay? And now we have lots of other things added to make bronze with copper. So sometimes we can have copper and some other metals like aluminium, manganese, nickel, even sometimes some non-metals or metalloids are being added like arsenic, phosphorus, or even silicon. So because of this ambiguity, we can't draw up a chemical formula for bronze. So let's just consider A, option A. So let's look at bronze and sodium chloride. Of course, bronze cannot be set up with a chemical formula, but sodium chloride, we know that NaCl, all right, our common salt. Okay, let's look at copper. Copper is definitely Cu, and sodium chloride NaCl, so it doesn't fit. So let's look at caustic soda. Caustic soda, that is NaOH, sodium hydroxide, and we have washing soda, that is Na2CO3. So they are being represented with a chemical formula. So the pairs that cannot be represented with a chemical formula, they are air and bronze, option A. We have question 40 right before our face, okay? Consider the equation below. We have this, okay, Cr2O7 minus, okay, plus 6 of iron, okay, 6Fe2 plus 14H plus, to give you 2Cr3 plus 6Fe3 plus 7 moles of water. So definitely this equation we have before us, they are being presented in their ionic form. So we are asked to find the oxidation number of chromium, the changes in the oxidation number of chromium from the reactant side to the product side. So let's examine this together. This is going to be very easy to do. So we have on the reactant side, we have Cr2, okay, O7 2 minus. Okay, for a compound normally, the oxidation number in some it's equals to 0, but right here this is an ionic form, so it's going to be equals to -2, okay? So at first we have to find the oxidation number of chromium here. So I will say chromium is 2, okay? We have 2 represented here, pardon, okay? So plus oxygen, we have 7 of it, and we know that the valency of oxygen is -2. All right, okay, so we have 2Cr, 7 times -2, that is -14, okay, -14, minus times plus, that is minus, okay, all right, so equals -2. If you collect like terms, then I have -2 plus 14, and that should give us, okay, -12, or that should give us +12, okay, 14 is higher than this, +12 rather. So we have 2 of chromium equals 12, divide both sides by 2, the coefficient of chromium. So that means the oxidation number of chromium here is 6. Okay, so you're switching from 6, and if you check on the product side, we have it as, You can see that means it's 3 plus. So it's switching from, the oxidation number changes from +6 to +3. Okay, so let's go through our option. +6 to +3, the option is B. Question 41. Which of the following is a physical change? So what are physical changes? They are changes that they are easily reversible, and usually no new products are formed. Like for instance, dissolving salts in water, magnetizing and demagnetizing an iron rod or an iron object. Okay, so let's go through this. Option A, exposing white phosphorus to air. That is extremely flammable. Exposing it to air, spontaneously it ignites and burns with a yellow flame. And this had to even be put into caution because factory workers producing matches with white phosphorus had a lot of damages to their bones, even brain damages, and the dense white film, it's not even good for the eyes. So this is definitely a chemical change, so it's out of it. Burning kerosene, we know that very well. That's a domestic fuel that we use, so it's a chemical change. Dissolving calcium in water, wow. So that is a very vigorous reaction. You realize that in that process, after some seconds, after you drop it into water, after some time, you realize that calcium hydroxide is formed, that is slaked lime, and hydrogen gas, and that is extremely flammable too. So make sure that carrying out this experiment is in a well-ventilated place. So this is also a chemical reaction because it is also giving off. Then we have option D, freezing of ice cream. So you can freeze your ice cream and you can also melt it. It's easily reversible. So this is definitely a physical change. Option D is correct. Okay, question 42. In the reaction between sodium hydroxide and tetraoxosulfate 6 solutions, what volume of 0.5 molar sodium hydroxide would exactly neutralize 10 centimeter cube of 1.2 molar tetraoxosulfate 6 acid? So at first we should recall that this is definitely a neutralization reaction between an acid and a base, okay, to produce salt and water only. So this is the salt, this is the water produced, okay? It's a neutralization reaction like I mentioned. So this is the acid here. 1 mole of the acid reacts with 2 moles of the base to give you 1 mole of the salt and 2 moles of water. So if I want to write out the number of moles for the acid, okay, number of moles for the acid is 1. Number of moles for the base, okay, that's 2. All right, so for the reactant side. So recall that the formula for molar concentration is Ca, that is concentration of the acid, times volume of the acid over concentration of the base times volume of the base equals number of moles of acid over number of moles of the base. Okay, it's super easy. So we are asked to find the volume of the acid, that is Vb. We are looking for Vb. So let's make Vb the subject of the formula. All right, so we would have CaVa multiplied by Nb, okay? All right, over, okay, which equals to the other side. Okay, let's just deal with the equals first. Equals Cb Vb Na. Okay, so we are asked to find the volume of the base, volume of sodium hydroxide. So that means we are dividing both sides by Cb and Na. So over Cb Na. Okay, so this strikes out on the right hand side. So on the left hand side we bring it again. So we have Cb and Na, Cb and Na. Okay, so this forms the formula that we'll be working with. So we are looking for Vb, which is CaVa times Nb over Cb Na. All right, so let's plot in the values. What is the molar concentration of the acid, the molarity of the acid? Ca, that is 1.25. Ca is 1.25, okay? VA is 10 centimeter cube, all right? NB, that is 2, okay? CB, that's the molarity of the base, is 0.5, all right? Okay, then we have Na, which is 1. So let's slot in the values, okay? So we have Ca, which is 1.25 multiplies Va, that is 10, okay, times Nb, that is 2. All right, okay? So we have Cb, which is 0.5, okay, multiplies Na, that is 1. Okay, this is very, very easy to solve. Okay, so what we multiply through, what we would have is 1.25 times 10, okay, that is 12.5. 12.5 times 2, that gives you 25 over 0.5. Remember, 0.5 means 1 over 2. So I can just simply say 25 divided by 0.5 or 25 divided by 1 over 2, okay? Which means 25 over 1 times 2 over 1. That is 25 times 2, that is 50 over 1. That is still equals to 50 in cm cube, okay? In cm cube. So our answer is 50. So let's go through our options together. Option D. Question number 43. Sulfur exists in 6 forms in the solid state. This property is known as what? Okay. A, isomerism. This is when you see compounds when they have the same chemical formula but different chemical properties, okay, and different chemical structure. Their structures are different. They just share the same chemical formula. So this is definitely not isomerism. Okay, let's look at allotropy. This is when a particular element or a particular substance can exist in 2 or more different physical forms. Okay, so allotropy is definitely our answer. But let's look at isotopy. Isotopy means a particular element has a stable number of protons but different number of neutrons. Okay, so the neutrons vary. Examples like chlorine has different isotopes, okay, and that means that the atomic mass is going to differ due to difference in their neutron number. And isomorphism deals with crystals, okay, crystals of different chemical compounds or chemical elements, chemical compounds majorly, they have similar shape. Okay, this deals with crystals, this deals with difference in neutron number. This is definitely difference in physical form of the same elements under check or under inspection. Then we talk about isomerism, okay, the same chemical formula but different chemical property and different chemical structure. Okay, so definitely our option is B. So don't forget how important it is for you to practice with our simulated Myschool CBT exam practice, okay, for the mobile app, which we have it as the Myschool CBT exam for the mobile app. We also have the Myschool JAMB CBT exam for software. You can access this through the links I have provided in the description below. It is good for you to practice with this app on your mobile phones or your smartphones, and also with the softwares on your computers or your laptops and what have you. So we are rolling on to question number 44. So in the reaction M plus N to give you P, okay, so we have the enthalpy change of the reaction as being positive. Okay, that means that heat is being tapped from the surrounding into the system. Okay, so these are the reactants and these are the products. So let's observe the reaction and let's see which of the following would increase the concentration of the product. Okay, so which of them will guarantee that we have more products. Okay, so adding a suitable catalyst, that would have been a good idea, but what catalyst does is that at first it can affect the activation energy or alter the mechanism of the entire reaction. Okay, So let's just put that in consideration somewhere. Increasing the concentration of P, oh, of course not. P is the product. So because we want to increase the concentration of the product doesn't mean we have to increase the product. We just have to increase the reactant to give us more products. Okay, just as concentration affects solids, so also pressure affects gases. Okay, so let's look at option C, increasing the temperature. I think that is very juicy. When you increase the temperature of the system, it makes two things to happen. Okay, it makes two things to happen. The first one can be that the number of particles with enough energy to overcome the activation energy, it will increase. So more particles will have enough energy to increase, or probably it can also increase the average kinetic energy of the particles in the system. So increasing the temperature, and that is a very good one for us. So we have decreasing the temperature. Now when you decrease the temperature, it's going to slow down the rate of the reaction. So definitely option C, increasing the temperature, we guarantee that we increase the concentration of the product P. So don't forget to hit the like button, click on the subscribe button, and tap on bell notification to get informed as we release the next videos. Question 45. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of this unknown compound is 180, find the molecular formula. So the first step we are required to take is just to have something like this. We have carbon, the constituent element, carbon, hydrogen, and oxygen. Okay, so we have the percentage of carbon in this compound is 40. All right, okay, the percentage of hydrogen is 6.7, and the percentage composition of oxygen is 53.3. Okay, so we just recall that for their weight of their atom, for carbon that is 12, okay, for hydrogen that is 1, for oxygen that is 16, okay, their proton number plus their neutron number gives you this. Okay, so 40 divide this, you should have something somewhat around 3.33. 6.7 divided by 6.7 still gives you 6.7. 53.3 divide 16, you're still going to have something around this figure. Okay, so the rule is just that you divide through by the lowest value, and the lowest value is 3.33. Okay, this is super easy. Okay, this becomes 1. This is roughly 2, okay, this is 1. Okay, so that means what would have is, okay, so you just have an idea that the compound we are trying to prescribe to us is going to have C1, okay, H2, okay, and O1. Okay, so that is whatever the value of carbon is, hydrogen we have times 2 of it, and whatever the value of oxygen is going to be, hydrogen we still have times 2 of it. Okay, so just have that at the back of your mind. So let me just write this out properly. So the empirical formula we have here will be CH2O, okay, and equals the molar mass of the compound, the unknown compound, which is 180. Okay guys, so recall that carbon is number 12, okay, plus hydrogen is 1, the mass is 1. 1 times 2, that gives you 2, plus oxygen, that is 16, equals 180. So if we add up what we have in the bracket, 12 plus 2, that is 14, okay, 14 plus 16, that is 30. So we have 30 and equals 180. Okay, divide both sides by 30. 0 cancels 0. 3 in 18, that is 6. So definitely n is 6. So if we're going to put n into this bracket, So that would be CH2O, okay, 6. So if we expand the bracket, so we should have C6, okay, 2 times 6, that is 12, H12, okay, 1 times 6, that is 6, 0, O6 rather, that is oxygen. So this is definitely a sugar. This is glucose, okay? Alright, so the compound we are looking for, the molecular formula for the compound we are looking for is C6H12O6, and that is glucose. So let's go through our option. That is option C. Question number 46. Okay, the IUPAC nomenclature of the compound, you can see it as it is written out. Okay, IUPAC means International Union of Pure and Applied Chemistry. So they have a standard way of giving names to compounds, okay, hydrocarbon compounds or normal organic compounds. Okay, so let's look at this very well. So when we want to name an hydrocarbon, there are just few rules that you just have to keep in mind. Okay, at first you have to observe the straight chain that is the longest, okay, and this is what we have, okay. And also, if you want to start naming, you have to observe if there is presence of more than one bond, okay. If we have double bond at any point, so that makes it an alkane group, ENE, okay. When we have triple bond, that is an alkyne group, that is YNE, okay. So this is just a single chain, okay. So a single bond, so that is definitely an alkane. So now let's count the number of carbon atoms standing, okay. We have 1, we have 2, okay, we have 3, we have 4, we have 5. So that makes it pentane. Definitely is a pentane. You can see the ones in brackets, they are the alkyl group attached to it. They are just a branch chain. So if we want to identify the locations of this alkyl group, it's good we start naming our compound from the point that is closest to the branched chain. Okay, so if you look at this is number 1, number 2. It's quite far from the first branching. So, but if you look at it from here, this is 1, then the next has a branching. Okay, so we are going to start from here. So this makes number 1. Okay, so on number 2 we have an alkyl group. Okay, which this is methyl. So that is, we have number 2. Okay, then we have 3. Number 3. Okay, so that is, we have 2, 3. How many methyls do we have? 1, 2. That is di. So definitely we have 2, 3 dimethylpentane. Okay, so 2, 3 dimethylpentane. That makes option B very correct. Okay, question number 47. Which of the following gases contain the least number of atoms at STP, standard temperature and pressure? Okay, so now let's go through each one of these gases together. So we have 1 mole of butane. So recall that butane belongs to the alkane family, and they have their general molecular formula as CnH2n plus 2. Okay, so where the number of butane, MEPB, that is number 4. So the number there will be C4, okay, H2 into bracket 4 plus 2. Okay, so we are going to have C4, 2 times 4, that is 8. 8 plus 2, that is 10. Okay, so this is definitely butane. Okay, so 1 mole of butane should contain, so this is times 1, it's still going to give you C4, H10. So 1 mole of butane contains 4 carbon atoms and 10 hydrogen atoms, making 14 atoms in total. Okay, just take note of that. Okay, so the second one is 4 moles of chlorine. So we know that a chlorine molecule is diatomic, that is 2 atoms are present. Okay, so we are told that 4 moles of it. So that is 2 atoms of chlorine, okay, times 4 mole. Okay, that equals 8. Okay, so 4 moles of chlorine gas will be 8 atoms to be present. Okay, we have 3 moles of ozone. Okay, 3 moles of ozone. Ozone is O3. Okay, is a triatomic gas. So that is 3 times 3. Okay, and that gives you 9. All right, so let's go to argon. 7 moles of argon. All right, take note of this. Argon is a monoatomic gas, just alone, like by itself. That is just 1. So 7 times 1, that's still equals to 7. So when you look through all of the options with me, you realize that the gas with the least number of atom is argon, number 7. That's 7, and that is option D. In case you have questions that you would like to ask, so don't forget that we have several solution providers on the Myschool website that are waiting to help you out. And I've helped you by also providing the link in the description below that will lead you to the Myschool website where the solution providers are happily waiting for you. So over to question number 48. What mass of magnesium will be obtained by passing a current of 2 amperes for 2 hours 30 minutes through molten magnesium chloride, given that 1 Faraday equals to 96500 coulombs, okay, and magnesium Mg equals 24. This is a very simple question to tackle. Take note that this is under electrolysis, and in electrolysis we know that 1 Faraday, okay, will discharge 1 mole of electron. Is that okay? So for magnesium, is an element that has 2 valent electrons. So that is, if 1 Faraday discharges 1 mole of electron, therefore 2 Faradays will be required to discharge 24, okay, 24 grams of magnesium. So 2 Faradays will be 2 times, okay, 2 times 96500. Is that okay? And when we multiply this, we should have rather 96500, okay? We can confirm this value with me, 96500, okay? So this should give us 193, I guess, very correct, 193,000. So that is, we know that 193,000 quantity of charge will deposit 24 grams of magnesium. And we are told that with a current of 2 amperes for 2 hours 30 minutes, remember quantity of charge Q equals IT, that is the current times the time. We have the current is 2, okay, times our time. We are given 2 hours 30 minutes. So recall that an hour equals to 60 minutes. So 2 hours will be 60 times 2, that is 120 minutes. But we are having 2.5 hours. That is 120 plus the extra 30 minutes, making 150 minutes. So that will be 2 times 150 minutes, okay, times 60 seconds. Okay, this is very, very easy. So if you multiply this all through, that is 2 times 150, that is 300. 300 times 60, that is 18,000. Okay, so we know that 193,000 will deposit 24 grams of magnesium. So how much will 18,000 quantity of electricity deposit? So we don't know. We cross multiply. Then we are going to have, okay, this is what we're going to have, 24 times 18,000, okay, divides this 193,000. So 0 strikes out 0. Okay, so by the time we'll solve this, we should arrive at 2.24 with other values. So this gives us the gram of magnesium that will be deposited when 18,000 coulomb of charge passes through the electrolyte. Okay, so the nearest to our answer is option D. Question 49. Which important nitrogen-containing compound is produced in Haber's process? So Haber's process involved tapping nitrogen from the air, hydrogen from natural gas, that is methane, okay, bringing them together to form ammonia. So the option that fits our answer is option A, ammonia. Now on to question number 50. Elements in the periodic table are arranged in the order of their, okay, so at first the periodic table was first constructed in 1869 by Dmitry Mendeleev. He was a Russian scientist, a chemist to be precise, an inventor, and a well-known lecturer in Petersburg University, that's Russia. Okay, so he constructed the periodic table and he fixed in elements to it according to their relative atomic mass. Okay, so but in modern times now, with the discovery of the electronic structure of an atom, we realize that the proper arrangement of elements in the periodic table is according to their atomic numbers. So option A is the correct option. So this is the end of this segment, but there are more videos to come, and I'm sure you're enjoying this content and you would like me to bring you more of them. So you just have to hit the like button, you have to click on the subscribe button, and you have to tap on bell notification to get informed as we release the next videos.